Europa is a moon smaller than our own, yet scientists estimate its hidden ocean holds twice as much water as every ocean on Earth combined. That ocean has been sealed under miles of ice for possibly billions of years, cut off from sunlight entirely, and it might be the closest place in the universe to answering whether you are alone. Moons are not one thing. Some are frozen solid, some are melting from the inside, some were kidnapped by gravity, and one type might be quietly building the rings around its planet. Type 1. Ice moons. Worlds where water hasn't just frozen on the surface, it dominates the entire body, layer after layer of ice down to a rocky core. Ganymede is the largest moon in the solar system, bigger than the planet Mercury, and its icy shell may be sitting on top of a salty ocean of its own. Many of these ice moons are ancient and nearly geologically dead, their surfaces a frozen record of craters carved over 4 billion years with almost nothing to erase them. Callisto is so heavily cratered that scientists call its surface saturated. There is no room left for a new crater to land without erasing an older one. Not all ice moons are silent. Enceladus fires plumes of ice and water vapor thousands of kilometers into space through cracks nicknamed tiger stripes near its south pole. Some of that spray falls back as fresh snow, meaning Enceladus may be one of the only places in the solar system where you could, in theory, watch snowfall in real time. That heat doesn't come from the sun. It comes from gravity itself, relentlessly flexing these moons as they orbit, a force that, turned up to the extreme, creates something entirely different. Type 2. Lava moons. Take that same tidal flexing and turn it up, and instead of an icy shell you get a surface that never stops erupting. Io is the most volcanically active body in the entire solar system, with more than 400 active volcanoes constantly resurfacing its surface. Io orbits Jupiter, and the combined gravity of Jupiter and two neighboring moons stretches and squeezes its interior, generating enough friction to keep rock permanently molten. Some of Io's volcanic plumes shoot material more than 300 kilometers above the surface, far higher than any volcanic eruption ever recorded on Earth. The lava resurfaces the entire moon so quickly that Io has almost no impact craters left. Its surface renews itself within roughly 1 million years, a blink in solar system time. That makes Io, right now, the most volcanically extreme body we know of in the entire solar system, more active than Earth, Venus, and Mars combined. Not every moon formed alongside its planet, though. Some arrived from somewhere else entirely, captured mid-flight by gravity that was never supposed to catch them. Type 3. Captured moons. These aren't leftover material from planet formation. They're asteroids or small worlds that wandered too close and got trapped by gravity. Mars' two moons, Phobos and Deimos, are small, lumpy, and irregularly shaped. Exactly what you'd expect from captured asteroids rather than moons born in a smooth accretion disk. One giveaway is the orbit itself. Moons that formed alongside their planet tend to circle in the same direction the planet spins. Captured moons often don't. Neptune's moon Triton is the most extreme case. It orbits backward, opposite to Neptune's own rotation, something essentially impossible for a moon that formed in place. That backward orbit means Triton is slowly spiraling inward, and tens of millions to billions of years from now, it will likely be torn apart by Neptune's gravity. Despite being a captured object, Triton is geologically active, with nitrogen gas geysers erupting from its icy surface, proof that capture and complexity aren't mutually exclusive. Triton's surface temperature sits near -235 degrees Celsius, among the coldest ever measured in the solar system, and it still finds enough energy to erupt. Capture explains where a moon came from. It doesn't explain what a moon does once it's there, and some moons have a very specific, very strange job. Type 4. Shepherd moons. These small moons orbit right at the edge of a planet's rings, and their gravity is the only thing keeping those rings intact. Saturn's narrow F ring is held in place by two tiny shepherd moons, Prometheus and Pandora, orbiting on either side of it like gravitational fences. As ring particles drift outward, one moon's gravity tugs them back. When they drift inward, the other moon pushes them out again, a constant gravitational correction. Remove those shepherds, and ring dynamics models suggest Saturn's F ring would gradually lose its sharp, narrow shape. Astronomers predict it would eventually spread out, though the exact timescale is still debated. It's a strange career. These moons don't shine or erupt, they just quietly pull on ice particles for billions of years, the least glamorous, most essential job in the solar system. Other moons like Pan and Daphnis don't guard a ring's edge. They carve gaps straight through it, sweeping clear lanes as they orbit inside Saturn's rings. Pan even grows its own equatorial ridge from swept-up ring material, giving it a shape scientists compare to a walnut, a moon quite literally built by the rings it patrols. Type 5, the most extreme, ocean worlds. Moons hiding liquid water beneath their icy shells, and in a few cases, maybe the ingredients for life. Europa's ocean stays liquid not from sunlight, but from tidal heating, the same gravitational flexing that powers Io's volcanoes next door, just gentler and hidden under ice. Hubble and James Webb have both detected what may be plumes of water vapor erupting from Europa's surface, offering a possible way to sample that ocean without ever landing. Enceladus went further. NASA's Cassini spacecraft flew directly through its plumes in 2015 and detected hydrogen gas, a possible sign of chemical reactions on the ocean floor. Those reactions resemble hydrothermal vents on Earth's ocean floor, the same kind of environment where some scientists think life first began, though that remains a hypothesis, not confirmed evidence. Here's the catch with studying Enceladus. A radio signal from Saturn takes over an hour to reach Earth, so if Cassini had shouted, "I found life," we'd have waited 80 minutes to hear the punchline. Titan, Saturn's largest moon, is even stranger. It has rivers, lakes, and rain, but made of liquid methane and ethane, the only other place with stable surface liquid. Beneath Titan's methane weather, scientists suspect a subsurface layer of liquid water too, meaning this single moon might have two entirely different oceans stacked on top of each other. Even Ganymede, the ice moon from earlier, is now suspected to hide a salty subsurface ocean of its own, meaning ocean worlds might be common, not rare, among icy moons. None of this confirms life. Every one of these oceans is a candidate, not a discovery. The ingredients might be there, but ingredients are not the same as a meal. NASA's Europa Clipper, launched in 2024, is on its way right now to study whether Europa's ocean could actually support life. If life is ever found in one of these oceans, it would mean life started at least twice in a single solar system, once here and once in the dark under solid ice. Every moon out there is running its own experiment, frozen, molten, kidnapped, or working, and the most important one might be running silently, right now, in the dark under the ice. Subscribe for more of the solar system's strangest rules. Next time, we're ranking the most violent ways a planet can die.